With today's new lesson, we're going to be looking at factoring different polynomials. Today is the first lesson in our mini factoring unit. It is F.1. The title is Factoring the GCF. GCF does stand for Greatest Common Factor. So as you're writing your objective down, I will be able to factor by pulling out the GCF. Once you have your title and objective down, go ahead and move on. We're going to start pretty basic, just looking at two terms and making sure we understand the idea of a greatest common factor. When you look at 8x and 16, the first thing I'd like you to notice is the first term has an x, but the second term does not. So they do not share an x in common. What they do share is the numbers 8 and 16. So we're going to look at the factors. What is the largest number that can divide into 8? Well, 1 goes in evenly, 2 goes in evenly, 4 and 8 all go into 8 evenly. As far as 16, 1 goes in, 2 goes in, 4 goes in, 8 goes in, and 16 goes in. So the question is, what is the greatest common factor? Well, they both have a 1, they both have a 2, they both have a 4, and they both have an 8. So the greatest number they share in common is an 8. Now, if you are comfortable with your multiplication facts, you should be able to look at 8 and 16 and know that 8 is the biggest number that goes into both. But just in case you've ever wondered what a GCF is, that's what it is. That is the largest number that goes into both. So the GCF for those two terms is simply 8. Now let's look at the next one. It's a little different. When we look at the coefficients 2 and 8, the largest number that goes into 2 that also goes into 8 is 2. The other thing that's different here we're going to look is x squared. Remind yourself from earlier in this unit, x squared means x times x. There are two x's being multiplied. The second term just has one x. Well, what do they both have in common? They both have at least one x. So we can say they share an x. They both have at least one. Now here's where this gets interesting. We're going to write what is left over if we divide or pull out that greatest common factor 2x. Just to give you a visual of what that looks like, I'm going to move this out of the way. We said 2 divides into both of these numbers, so we would divide it by 2, and then that would leave us 2 divided by 2 is 1. And then of these two x's, we pulled 1 out, which means there's 1 remaining. So that would be 1x. If we look at the next term, 8x, 8 divided by 2 is 4. And there was only 1x, and we pulled it out, so there are no more x's. So remaining is the 1x and the 4. But the question is simply asking, what is the GCF? So the greatest common factor we were able to pull out is just the 2x. On our next slide, we will look much more closely on what is left over in parentheses. The main thing I need you to see right now is that 2x is what they both shared in common. Now, let's look at what distributing is. Distributing, which is multiplying, is the opposite of pulling out the greatest common factor. So I quickly want to make sure we remember how to distribute, because distribution is how we're going to check ourselves in just a few moments. Remember, when a number or term sits outside parentheses, you distribute or multiply. Please remember your exponent rules from earlier in this unit. 2 times 4x squared would be 8x squared. 2 times 7x is 14x. 2 times negative 3 is negative 6. None of these three terms are like each other. None of them are to the same variable, to the same power. So we are done. Let's look at the next one. We have 3x being distributed. Remember, you're going to multiply coefficient times coefficient and get 12. And then you're going to add exponents of like letters. So that would be x to the third power. 3x times 9x is 27x to the second power, because don't forget you have the 1 and the 1 when you add your exponents. 3x times 2 is 6x. All three terms do have an x, but they are not all to the same power, so that is it. We are done. There is no combining of like terms. The answer is a third degree trinomial, because there's three, so third degree trinomial with a leading coefficient of 12. That vocabulary should seem pretty comfortable at this point. So now let's identify the greatest common factor, and we're going to pull it out. We're going to divide it out. We're going to factor it out. They all mean the same thing. Looking at 4x plus 8, when I look at 4 and 8, 1 goes into both of those, 2 goes into both of those, and 4 goes into both. So 4 is the greatest common factor that I'm going to pull out. The 8 does not have an x on it, so I cannot pull an x out. What we want to write in parentheses is what remains. Well, if I'm dividing out or factoring out the 4, it's kind of like I'm dividing them by 4. Well, 4 divided by 4 is 1. There's my 1x. And then 8 divided by 4 is 2, and it's a plus, so plus 2. So I could simply say 4 times x plus 2. Remember, we don't have to write the 1. That is it. That is all we are practicing. We will eventually get to where this is set equal to something and we will solve it, but right now we're just practicing the skill of factoring out the GCF. One thing I do want to point out that you're not going to be required to do, but you can do to check yourself. Remember, we just practiced distribution. If I multiply 4 times x, I will get 4x, and 4 times 2 is 8. That is, in fact, the original binomial that we started with. So I know my factoring in my blue square right here, my factoring was correct. Now let's look at the next one. Similar, but a little different. When I look at my two terms, they both share a common factor. The greatest number that can divide evenly into 9 and 36 is 9. Now look at their variables. This is x squared, which means x times x, and this is just an x. They both have at least one x. So I'm going to say they share one x. So now in parentheses, let's write what remains. Well, we're dividing out a 9, so I'm going to divide them both by 9. Well, 9 divided by 9 is 1, so there's my 1. And it was 2 x's, but I pulled 1 out, leaving me with 1 x. The next one is 36 divided by 9, which is 4. I only had 1 x, and I pulled it out over here, so there are none left inside here. So if we look at that, we would have 9x times x plus 4. Let's just double check that we did in fact do it correctly. If I distribute my outside term, kind of like let's undo the factoring, 9x times x, remember you're going to add your exponents, would be 9x squared. 9x times 4 would be 36x. Does that match the original binomial? Yes, it does. That means our factoring inside the red box is correct. Just a reminder, you are not going to have to prove it by distributing. I just want you to know there is a way to check your work. If you're comfortable with those examples, then go ahead and move on to the next two. Looking at 8x squared minus 30x, the greatest number that can go into 8 and 20 is 2. And they both have at least one x. So we could say they share x to the first power. Let's write down what remains. I'm going to divide out the 2 that I pulled outside. That means they both get cut in half. So that leaves me with 4. And then if it was x squared, meaning there were 2 x's, and I pulled one of them out, that leaves 1 remaining for the first term. Now looking at the next term, the negative 30 divided by 2 is minus 15. There was only one x, and we pulled it out, so there are no more x's. So our answer is just 2x times 4x minus 15. Double check that we did it correct. This would become 8x to the second power, and this would become minus 30x. That does in fact match the original polynomial, so I know I did it correctly. Take a moment, pause the video, and do the next one. When you're done, unpause it and check your work. How did you do? Did you see that 2 was the greatest number that could divide into 6 and 22? If you divide them both by 2, you will get 3 and 11. So that's where this 3 and this 11 came from. This has 2 x's being multiplied, and this has only 1. So they only share x to the first power. That's why we pulled out the x to the first. If I want to prove that I am correct, I could distribute. This would be 6x to the second power, and this would be 22x. That does in fact match the original binomial. So I know for sure that my answer in gray is correct. When you feel comfortable with those, go ahead and move on. Here's our next two examples. 9 and 33 share a factor of 3. 3 can be divided out of both of them. Now look at both of them. They both have at least one x, so we can pull an x out of both of them. And they both have at least one y. The first term has 2, but the second one only has 1, so they only share a factor of y to the first power. Now notice I wrote that a little bit differently. 3xy is the greatest common factor. That's what can be divided out. Now we're going to simply reduce each fraction. 9 divided by 3 is 3. The x's reduce or simplify because 1 minus 1 is 0. The x's cancel. And if we look at our y's, y to the second over y to the first is just y to the first. Plus, let's go ahead and reduce 33 divided by 3 is 11. X squared over x to the first, 2 minus 1 is 1, so that's x to the first power. And then the y's cancel. So let's see, did that make sense? Are you comfortable with the way I showed my work? If I double check to make sure I'm correct, 3 times 3 is 9. xy times y is xy to the second, because we can only add exponents of like letters. 3 times 11 is 33. There's an x and an x, so that's x squared, and then just the y. That does in fact match the original binomial. That means my factoring here is correct. So let's look at the next one and see if that way of writing it as a fraction makes sense or if that's more confusing. What is the greatest number that can go into 25 that can also go into 15? 5 is the greatest factor they share in common. So when we get ready, 5 we're pulling out. Now look at the x's. There are 2 here and only 1 here. So they both only have an x to the first power. Now look at your y's. This is y to the first and y to the second. They both have only at least 1 in common, so we can only take out y to the first power. So the greatest common factor that we can pull out is 5xy. They both share factors of 5x and y. So now let's simply reduce the fractions and see what it simplifies to. So we've got 25 divided by 5 is 5. X squared over x is just x, and the y's cancel. Second fraction, 15 divided by 5 is 3. The x's cancel. Y to the second over y to the first is just y. Let's go ahead and make sure that we did in fact factor that correctly. Let's double check our work. 5 times 5 is 25. X times x is x to the second, and then just the y. 5 times 3 is 15. X y to the second power, because there's 1 and 1 is 2. That does in fact match the original polynomial, which means I did in fact factor it correctly. So if you do not like this way of writing it as a fraction, you do not have to. Another way to redo this exactly the same way would be to simply say 5 goes into both numbers, they both have at least one x, and they both have at least one y. So I could ask myself, what could I multiply 5 by to equal 25? Well, that would have to be 5. What letters would I have to multiply by to make my xy out here equal my x squared y? Well, the only thing it's missing is an x. Let's go this way. 5 times what is 15? That would be a 3. I already have the 1x, but I'm missing one of the y's, so that's what I would put inside. Just another way to get to the exact same answer. So kind of take a moment and pause and see which way of thinking works best for you. Now we're going to look at something a little differently that's going to get us ready for an upcoming lesson. When you look at number example 11, you will see two terms. Here's our first one, and here's our second one. They just look a little different. What I'd like you to see is they both share a factor of x plus 5. So that could be the greatest common factor that we pull out. What remains? The 3x and the plus 7. That's it. That's all we're looking for. We will be using this skill more in upcoming lessons. Look at number 12. They both have an x plus 2. And what remains is the 6x plus 5. That's it. That's all we're looking for. All right, for the last two examples, I would like you to go ahead and change them to the problems as I have written here on the video. This is one way that I will be checking your notes that you did in fact change these two polynomials. Here's what I'd like you to notice about number 13. There are 4 terms. That makes it a polynomial. What you're going to do anytime you have 4 terms is you're going to group the first two, and then you're going to group the second two. Notice I kept the plus in front of the 6 because you always take the sign in front of the number. Look at the first two terms, x squared minus 12x. The biggest number that can go into 8 and 12 is 4, and they both have at least one x. So the greatest common factor is 4x. That leaves me with 2x minus 3. If you're not sure how I got that, we divided these both by 4. That's where I got the 2 and the 3 from. This was x squared in the first term. So there was 2, but I only pulled 1 out, so there's 1 remaining. The other one had x to the first power, and I pulled 1 out, so there were no x's on the second. Now look at the next one in green brackets. The greatest number that goes into 6 and 9 is 3, so I'm going to pull out a 3. What does that leave me with? If I divide them both by 3, I will get 2x minus 3. Do you see how this looks like the last two examples we just finished? They both share a common factor of 2x minus 3. So because they share that factor, we pull it out, and it leaves us with 4x plus 3. That's it. Go ahead and pause the video, do your final example on your own, and come back to check yourself. So how did you do? Were you able, in the blue brackets, to pull out a greatest common factor of 5x, and then realize x minus 11 remains? And then in green, did you pull out a common factor of just a 2? And that leaves you with x minus 11 in parentheses. Both terms share an x minus 11, so that is the first factor we pulled out. And then what remained was the 5x and the plus 2. If you are feeling comfortable with factoring out the GCF, you are done with your notes and you are ready to ask for your assignment when you return to class.